Hi students, I am your chemistry miss Mrs. Anbumalar, 11th standard chemistry. Today we are going to see the continuation for the lesson 1. The topic name is gram equivalent mass. Previous lesson we completed the molar mass, relative atomic mass and gram molecular volume. So how to calculate the number of atoms or number of moles in that atom. So that is we are studying the previous lesson. Today we are going to see the so what is mean by gram equivalent mass. So what is mean by gram equivalent mass? First we are going to see the what is the definition of gram equivalent mass. What is gram equivalent mass? So gram equivalent mass is defined as the mass of an element that combines or displaces mass of an element that combines or displaces 1.008 gram of hydrogen or 8 gram of oxygen and 35.5 gram of chlorine. Okay, so this is the definition of gram equivalent mass. What is mean by gram equivalent mass? The mass of an element combines or displaces 1.008 gram of hydrogen or 8 gram of oxygen or 35.5 gram of chlorine. What is this? This is the atomic mass of hydrogen. 8 means that is the atomic gram of oxygen. This is the atomic mass of chlorine. Okay, so these are all that's the mass of an element. So here how it can be explained. That is the first one. How it can be explained. First one is example, zinc when react with sulfuric acid, how many amount of hydrogen is there? 2 molecule of hydrogen is displaces hydrogen molecule, that is zinc sulfate. How to read this equation? So 1 mole of zinc react with sulfuric acid to converted into zinc sulfate. The 1 mole of zinc is replaces 1 mole of hydrogen. So in this reaction 1 mole of zinc displaces 1 mole of hydrogen. The molecule is 1 molecule of hydrogen is 1.008. So 2 into 1.008. So what is that answer? So that is 2.016. So how to so mass of zinc required to displace 1.008 gram. So that is 1 mole of zinc is replaces 2.016 gram of hydrogen. But so what is the mass of zinc? So that is the zinc atomic mass is 35.38. So mass of zinc required to displace 1.008 gram of hydrogen. So how to calculate? So here what is the from this equation 1 mole of zinc is replaced 2 mole of hydrogen. So that is atomic mass of hydrogen is 1.008. So 2.016 gram. Okay, so that is the 1 mole of zinc replace hydrogen. So mass of zinc. So what is 1 mole? This is the atomic mass of the zinc. 60.38 mass of zinc required to displace. How to calculate? That is 65.8. So D places that is 2.016. Atomic mass of hydrogen is 1.008. So here that is 2. So this is 1. So what is the answer? 65.38 divided by 2. So the equivalent mass of zinc is 3269. The equivalent mass of zinc. So this is the equivalent mass of zinc. The equivalent mass, that is no unit is there. So no unit for equivalent mass, but is the gram equivalent mass. The gram equivalent mass, number of gram containing. So that is gram equivalent mass equal to 32.69 gram equivalent minus 1. So this is the another one. So next one is the gram equivalent mass has no unit, and another one is gram equivalent mass containing. So what is the gram equivalent minus 1? So next one is based on this. So 3 reference, namely hydrogen. So here that is the number of hydrogen, oxygen and the chlorine. So that is we cannot conceive the reaction only the 3 reference. Therefore, a more useful expression, gram equivalent mass. So, how to calculate? What is the definition of gram equivalent mass? First one is, what is the definition? So gram equivalent mass equal to molar mass divided by equivalent factor. So next we are going to see what is meant by equivalent factor. So what is meant by gram equivalent mass, molar mass by equivalent factor. So what is meant by equivalent factor? That is equivalent factor that is based on the basicity or acidity. So acidity or the basicity of that given element. So that is equivalent factor. Basicity. What is meant by basicity? First one is the acids. So what is meant by basicity? So what is meant by basicity? Number of moles of insoluble hydrogen ion, 1 mole of the acid. So what is meant by basicity? Basicity means that is basic. So that is the what is meant by equivalent mass equal to molar mass of acid divided by basicity of the acid. So what is meant by basicity? So number of replaceable hydrogen ion. So simply you reminder, so number of replaceable hydrogen ion. So say for example H2SO4. How many number of hydrogen is there? So that is hydrogen. So what is the basicity of the sulfuric acid? That is the 2. So what is that meaning for that? Number of replaceable hydrogen ion. So that is the basicity equal to 2. Okay, so that is the basicity 2 equivalent mole minus 1. So this is the another one. So this is the molar mass of, how to calculate the molar mass. So how to calculate the molar mass of sulfuric acid, H2SO4, that is the sulfuric acid. What is meant by basicity? Number of replaceable hydrogen ion. So from this equation, so that is called as basicity. So that is molar mass of sulfuric acid equal to, how to calculate? How to calculate sulfuric acid? Hydrogen atomic mass is 1 into 2 plus sulfuric acid is 1 into 32. Atomic mass of sulfuric acid is 32, right? So then again oxygen sulfuric acid O4, that is 4 into 16, right? So that is 2 plus 32 plus 64. So what is that? Answer is 98 gram mole minus 1. So this is the gram equivalent mass. So this is the molecular mass or gram equivalent mass. So molar mass, gram equivalent mass or molecular mass, everything same. Okay, relative atomic mass, molar mass, molecular mass are the same thing. So that is the calculation of molar mass. So next one is how to calculate the gram equivalent mass of sulfuric acid. This is the formula, gram equivalent mass of sulfuric acid. Equivalent mass of sulfuric acid. How to calculate? What is the formula? So now molar mass 98, basicity of the acid. How much amount of replaceable hydrogen ion? So that is 49, 8 equivalent minus 1. So previous year this is for compulsory question. How many number of gram, how to calculate the gram equivalent mass of sulfuric acid? This is the important one. So that is nothing but sulfuric acid, number of replaceable hydrogen ion. So that is the basicity. What is meant by basicity? Number of replaceable hydrogen ion. இப்போ sulfuric acid இருக்குனா இதுல எத்தனை ஹைட்ரஜனை இதுல இருந்து ரிமூவ் பண்ண முடியும்? So that is 2 hydrogen can be removed from this sulfuric acid. That number is called as basicity of sulfuric acid. Okay, so this is the first one. Second factor is that is acidity. What is mean by acidity? Number of replaceable OH minus ion. Simply next one is what is mean by acidity? Number of replaceable OH minus ion. What is mean by acidity? Acidity, number of replaceable OH minus ion. So say for example KOH. So how many number of OH minus ion? So number of replaceable OH minus ion. How many OH ion replaceable from this one? That is only 1. So that is acidity become 1. So the next one is sodium hydroxide. Number of replaceable hydroxide, that is NaOH. So that is the another one, number of replaceable hydroxyl ion, that is OH minus ion. Again another same calculation here, that is E is equal to molar mass of the base, molar mass of the base divided by acidity of the base. Okay, so how to calculate KOH, that is the basicity. What is the basicity? That is the, what is the acidity, that is the 1 equivalent mole minus 1, that is the acidity, KOH acidity. Number of replaceable OH minus ion, that is only 1 can be replaced, so that is the 1. Okay, next one is molar mass of KOH. Molar mass of KOH. How to calculate molar mass of KOH? So that is atomic mass of potassium is 1 into 39. 1 into 39 plus 1 into 55 plus 4 into 16. Okay, so this is the KOH. So hydroxyl oxygen. So how to calculate? Sorry. So that is 1 into 39 plus oxygen, that is 16. 1 into 16 and hydrogen is only 1 plus 1 into 1, right? So that is 39 plus 16 plus 1 equal to 56 gram mole minus 1. Okay, so this is the first one. So next calculation is gram equivalent mass. How to calculate the gram equivalent mass of KOH? Gram equivalent mass of KOH. How to calculate? So that is the molar mass is 56 divided by, again only, so what is the basicity? So that is only 1. So equal to, divided by 1 means what is the answer? So again the same answer will be given. So that is 56 gram equivalent minus 1. Okay, so this is the gram equivalent mass of the basicity. Next one is oxidizing agent. Oxidizing agent, number of moles of electron. What is mean by oxidation? What is mean by reduction? What is mean by oxidation? Addition of oxygen, reduction, thus removal of oxygen. That is, we are already studied in 10th standard. But here, what is mean by oxidation? As the number of electrons are gained or lost by 1 mole of the reagent during the redox reaction. So that is how to calculate, again how to calculate the oxidizing agent is equal to molar mass of oxidizing agent, molar mass of oxidizing agent divided by number of moles of electron gain or number of moles of electrons gain or reduced, number of moles of reduced. Okay, so this is the another one. So how to calculate the KMnO4 is a powerful oxidizing agent, right? So how to calculate the molar mass of KMnO4? Molar mass of KMnO4. How to calculate the molar mass of KMnO4? That is, potassium is 39 plus manganese 55, 1 into 55, then 4 into 16, that is oxygen, right? So 39 plus 55 plus 64, what is the answer? That is 158 gram mole minus 1. So that is the acid medium. So this is the molar mass of potassium permanganate. So next we are going to calculate how to calculate the gram equivalent mass of potassium in acid medium is reduced during the oxidation given by the following equations. That is, I write one equation, potassium permanganate, the MnO4, potassium permanganate, that is minus, plus acid medium in, that is H plus, and the electron gain, so converted into Mn2 plus 4H2O. So how can be calculated? So what is the oxidation number of Mn? So that is plus 7 here. This is plus 2. Plus 7 is reduced into plus 2. So 5, how many electrons are gained? 5 electrons are gained. So that is N is equal to 5. So number of loss of electron is 5. 5 equivalent mole minus 1. So here the oxidation state of manganese is plus 7. Here oxidation state of manganese is plus 2. So these are how to calculate the oxidation state. We are studying the in the later lesson. So next one is N is equal to 5 electrons are gained. So that is 5 electron. It is reduced to Mn2 plus. So that is the number of 5 equal moles. So how to calculate the gram equivalent mass? Gram equivalent mass equal to 158 divided by number of electrons are gained or lose. So that is 31.6 gram equivalent minus 1. Okay, so this is the another one, gram equivalent mass. So that is the gram equivalent mass of potassium permanganate, 158 by 5, 31.6 gram equivalent minus 1. So this is the first. Next one. So next one is so next we are going to see the example how to calculate the equivalent mass of this given compound. So that is one example how to calculate. So how to can be calculated? So this can be explained on the basis of the mole concept. How to explain the chemical equation? So ferrous sulfate react with KMnO4 plus sulfuric acid H2SO4 react to form K2SO4 plus MnSO4 plus Fe2SO4 thrice and H2O. Okay, how to balancing the equation? So balancing the equation here, potassium sulfate. So here that is 2 potassium is there. So that is 2 KMnO4, right? So again another one is manganese. So manganese, potassium sulfate, manganese sulfate. How many sulfates are there? So again Fe2. So here sulfate, here 3, here 1. So that is the 8 molecule of sulfate. So here 10 molecule of ferrous sulfate. So here also 5 molecule of ferrous sulfate. So that is totally 10. So here 2 moles of potassium permanganate. So that is 2 moles of potassium. What is the molecular mass of potassium permanganate? 158 equal to 30.16 gram of potassium permanganate. So 2 into 158 equal to 316 gram of potassium permanganate react with 10 moles of KMnO4. Okay, KMnO4 reacts with 10 moles. 10 into 152 of anhydrous ferrous sulfate. So what is 152? That is the molecular mass of ferrous sulfate. So this is the molecular mass of ferrous sulfate. So you calculate your own 32 oxygen 15 iron. So you calculate that is the 152. So 152 the molecular mass of ferrous sulfate. 10 moles means that is 1520. So this is the anhydrous ferrous sulfate. So 31.6 gram of KMnO4 reacts with, so how much? 1520 divided by 316 into 31.6 equal to 152 gram of ferrous sulfate. So what is the meaning for this calculation? So here that is the here same thing. So here that is the MnO, gram equivalent mass of, that is 158. Molar mass of KMnO4 is 158. So here that is the same thing. So the 158 iron 258. 2 moles of 158 because 316 gram of potassium permanganate. So 10 moles of that is the, so the same answer will be coming, that is the 152 grams. So here that is the mole concept and the equivalent mass concept is also same. That is only one controversy one. So that is the another one. This is another calculation. Next we are going to see the what is meant by empirical formula and molecular formula calculation. What is meant by empirical formula calculation? What is the first you are going to see the what is meant by definition of empirical formula. What is mean by empirical formula? Empirical formula of a compound written with the simplest ratio to the number of this individual element. So that is, it is the simplest ratio, empirical formula of the compound written with the simplest ratio of the number different present in one molecule of the subscript. So here that is H2SO4. Suppose the given compound, so the hydrogen they are given 50%, sulfur that is 20%, oxygen remaining 30%. These are the given percentage. We can write the empirical formula of this compound. How to calculate? This is one simple calculation. How to write the empirical formula of this compound. What is meant by definition? So the definition is that it is the simplest formula written with the simplest ratio of the number of different atom present in the one molecule of the compound. So one molecule எவ்வளோ percentage compound simplest ratio convert பண்ணி எழுதுறதுக்கு பேர் தான் வந்து என்னது? That is the empirical formula calculation. First one is this is one example. I will give one example. First example, given percentage. So first one is the composition, carbon equal to 32% and hydrogen equal to 4% and the oxygen equal to 64%. Okay, so this is the given compounds, the given percentage of this compound. How to calculate? Now we are preparing one tabular column, right? This is one tabular column. Okay, first you are writing without changing this order given element. Okay, first tabular column given element, don't change the order. Carbon, hydrogen and oxygen. Okay, this is the given element. Next we are going to see the given percentage. What are the percentage given? So that is 32%, then 4%, then 64%. This is the percentage given. Next one is molar mass. What is the mass of this given element? That is molar mass. What are the mass of this element? So atomic mass of carbon is 12, right? Atomic mass of hydrogen is 1. Atomic mass of oxygen is 16. Okay, this is, you already know that, right? So next we are going to convert relative number of moles. How to calculate the relative number of moles? So again one formula, the given percentage divided by atomic mass. So okay, so the molar mass are given percentage by atomic mass. 32 divided by 12 equal to, simplify that, 2.66. Okay, so next we are going to see the percentage. How much percentage? 4. What is the molar mass? 4 by 1 is equal to 1. So next we are going to see the what is the percentage? 64. What is the atomic mass? 16. So what is that answer? That is the 4. Okay, this is also 4. So this is the equation. So this is the answer. Next we are going to see the next simplest ratio. This one is converted into simplest ratio. How to calculate the simplest ratio? So this is the, among these three values, which one is least value? This is the least value, right? So this is 4, this is 4, this is only 2.66. So according to using this one, now it is converted into simplest ratio. So what is the calculation? Next one, so divided by this 2.66. This is the least number. So again, so 2.6 divided by 4 divided by 2.66. Again, this is 4 divided by 2.66. Okay, so this is the 4. Next one is, this one become 1. This one becomes 1.5. This is also become 1.5. Okay, next one is whole number ratio. We want only the simple number, whole number ratio. Okay, whole number ratio. So how to calculate whole number? This is the, so 1.5, which number is multiplied, it is converted into whole number. 1.5 multiplied by 2 means that is 3. This is also 3, so you can multiply by 2. So 2, 3. So what is the empirical formula? Finally you write the empirical formula is how to write? So first you write the element. So that is carbon, hydrogen, oxygen, right? Carbon, what is the carbon percentage? 2. hydrogen is 3 and oxygen is 3. So this is the empirical formula of the given percentage. Okay, understand? First, what is the first step? First you write that element, you write that percentage, then you write the molar mass, then relative number of moles. How to write the relative number of moles? How to calculate? Percentage divided by atomic mass. Here also percentage divided by the atomic mass. Then which among these three values, which one is least value? You divided that number with that least value. So that is 2 that is converted into simplest ratio, 2.6 divided by 2.6. So everything you divided, that is simple ratio, that is the whole number. First you write that, change the number, so you can write this one. So next another one example. So another simple example, what is the given percentage? Given percentage, next example. What is the given percentage? Carbon equal to 40%, hydrogen equal to 6.6%, oxygen equal to 53.4%. This is the given percentage. Find the empirical formula of this compound. Okay, this is the first next question. So first column, that is the element. What is the first column? Element you can write. What is the given element? Carbon, hydrogen, oxygen. Next one is percentage. What is the given percentage? 40, 6.6, 53.4. Okay, this is the percentage. Next one is atomic mass. What is the atomic mass of carbon? 12, hydrogen 1, oxygen 16. That is also we know that. So next one is relative number of moles. What is the relative number of moles? So how to calculate the relative number of moles? So 40 divided by 12, 6.6 divided by 1. So 53.4 divided by 16. Okay. So next one is, you can simplify that. 40 divided by 12, what is that answer? 3.3. So 6.6 here, that is 3.3. So among these three values, which one is least value? So that is the simplest ratio. So next one is simplest ratio. What is that answer? How to calculate simplest ratio? Which one is among this value? 3.3. So 3.3 divided by 3.3. Here 6.6 divided by 3.3. 3.3 divided by 3.3. What is the answer? This is 1. This is 2. This is 1. Okay. So this is the simplest ratio. This is already whole number ratio. That is the whole number already is whole number is there. So straightly you whole number. So that is 1, 2, 1. Okay. So now how to write the empirical formula? The empirical formula is how to calculate. So how to write? Carbon, hydrogen and oxygen. So that is the number is right in the subscript of this individual element. So that is here 1 is there, here 1, that is 2, this is 1. So that is no need to write CH2O. This is the empirical formula of this given compound. Okay, so this is the another one. Next one is, this is the one assignment for you. This is one sum. Here that is a compound on analysis gave the following percentage. Carbon 54.55%, hydrogen 9.09%, oxygen is 36.6%. Okay, determine the empirical formula. Tomorrow after watch the video, you complete that problem and send reply to me. Okay, you show your note to me and send to that problem. Okay, you write in the classwork. This you can write 3 problem. That is the first example. This is the first problem. In your classwork you write them. This 2 problem, that is enough. Okay, this one, this is the first problem. Then again second problem, this is second example, this is the second problem. And the third problem is the evaluate yourself. This is the another one. This is evaluate yourself. Okay. Tomorrow you write in the classwork. Okay. Thank you children. See you the next video.